Next up is Lukasz Lewandowski from Swiss Re. Lukasz has an education in management and finance, but don't get fooled. He is an excellent cloud engineer and he is fluent in data and AI. And today he is responsible for the data platforms and for engineering at Swiss Re. And he will talk to us about the challenges, but also especially the solutions on how Swiss Re works with data. Lukasz, thanks so much for being here.
Thank you very much. Thanks for having me. Can everyone hear me? Yes. So yeah, I haven't studied physics, which I hope is not putting me on your bad side. But one of my hobbies is orbital mechanics, though.
I know.
Does that? Yeah.
I
so
know.
that counts. Thanks again for being here. So yes, I work at Swiss Re, and for those of you who may not know that much about insurance, because it's usually a very boring topic. Insurance's mission is to make the world more resilient. When something bad happens, you want to turn it into something at least, maybe not good, but not bad, right? And in some cases, you actually want to make sure that things get back on track quickly. This is, in fact, an explicit mission of Swiss Re, to make the world more resilient. If anybody wants to change the world, make it a better place, please come work for us. But we're at the data science conference, and we talk a lot about data, about information. If we try to explain what it would take to make the world super resilient, ultra resilient, in principle, you would need to know about all the risks and monetize it so that you can create processes, right, that make economic sense and work on that resilience. What do we mean by risk information? It's information about everything that can go potentially wrong. So information about every building, right, and how it's built and where it's located, about every car, about every company, about every person, right? We have health insurance, we have life insurance, and so on. That's what we mean. So like there is this idealized database of all risk. It doesn't really exist, but conceptually it's somewhere there. And if you had it, you could, in principle, make the world resilient to any kind of risk, right? Because you would be able to identify areas that you need to strengthen. So, in order for us to follow that mission and this vision of a very resilient world, we elevated data to a very, very strategic level at Swiss Re some time ago already. We have a common data asset that we've defined, that we acquire, that we integrate, that we curate, and so on. We build, and that's a hard constraint, we build all our decision support applications using that common data asset. We really try not to make any exceptions. And to make sure that we're not in a completely sort of automatic AI-only world, right? We recognize that ultimately the only way to continue to enrich that asset is by capturing the intelligence and the experience of our people. So any decision that is being taken, any observation, any insight, right, needs to be fed back into that system, right, and continue to add, sort of to accrue on top of that data asset. But it's obviously extremely easy to say, right, on a theoretical picture like this, but how do we actually do that in practice? Let me give you an example before we get into the solutions. So imagine there's a paper factory, right, big, 5 buildings, and imagine that it's somewhere, maybe, in the south of Italy. It's insured against fire and flood. We insure big corporates, and we have these types of risks in our books. Imagine there's a drought. Maybe because of the drought, maybe not, but fire starts, factory burns down. We receive an insurance claim. 100 pages of detailed information, reports from the incident, pictures, descriptions, well, the original policy as well, right? We need to look at that. Then we look at it and we realize there are anomalies, or maybe there are no anomalies. If there are no anomalies, we just pay and that's it, right? But we go through all this and realize there are anomalies. Maybe 3 buildings were listed in the policy, but 5 burned down, right? How do we settle that claim? Maybe the fire spread rapidly, but we look at the pictures and we don't see any sign of wind. We look at weather data and we realize that it rained in the morning, right? Things could be suspicious, right? And could not, it doesn't have to be malice, but there may be things that don't follow a single coherent story. The point is that all of these things raise a lot of questions, and eventually these questions will get answered. Some of them better, some of them worse, but they will get answered. The important thing is that the answers to these questions have an impact on any future, well, first of all, current claims handling process, but then future underwriting, future claims handling process, or even portfolio mix decisions. Are we going to continue to insure paper factories in areas affected by climate change? Could be a big investment decision to say no, allocation decision that we're going to say, no, let's not do that. It's too risky. We don't know how it's going to evolve. So these types of feedback loops exist. Many of them have been implicit, very often not fully digitized. These feedback loops in the past usually did not close in any particular system, right? Things were scattered across different systems in people's heads. Sometimes somebody would leave, expert on paper factories could leave the company, and most of the underwriting decisions of the past, right, and his knowledge, right, would just walk out through the door and never come back. One of the reasons we've built our data mesh was to essentially identify and then digitize all of these feedback loops. There are hundreds, if not thousands, of such feedback loops in a complex organization. They exist everywhere, on low levels, on mid levels, at the very top, right, where senior management decides where to invest and where to do business. And there's an interesting realization, right? When we work in a company like ours, we just realized that our company is just an information processing company. There's nothing else, right? We have no factories, we have no machines, right? We have no stock to worry about. Information comes in, goes through multiple nodes. Eventually, some information comes out, and a residual of that are cash flows. Some coming in, premiums, some coming out, claims that we settle, maybe in a roundabout way. We also invest, get some investment income, and so on, right? But what is actually happening is information flows through, nothing else. So we should be designing for this. This should not be a byproduct, right, of how we manage and how we build our salary. We should be designing for this. So since we wanted to capture all these feedback loops, we built a platform. And unlike in some of the discussions before, we've actually taken a very strong and principled approach to that. We said we're going to have one platform. Technically speaking, one platform. Big, risky strategic decision. We called it Stargate. So first head of Stargate sits over there. I'm the second head of Stargate. Pretty cool title. At one point it was actually on LinkedIn, I think. Now it's not anymore, but the name of the platform came from our CEO himself, apparently a sci-fi fan. What is Stargate? Stargate is at the very bottom, a data integration platform at scale. That is actually our data mesh, and I will go into that in a moment. It's a data lake-like environment that operates at scale. But this data lake environment is used to curate the data. We call this layer analytical data models, or ADMs. You can also think of them as data marts. You can think of them as an ontology. There are various terms that are used, but it's essentially curated data. This data is then connected to each other, and it's connected across the organization, from property and casualty underwriting, through claims handling, through risk management, through finance. We try to build all these flows on that curated data. But obviously, data itself is nothing without the ability to give it to our users and sometimes our clients. And on top of that, again, still within the same platform, we have built an ecosystem of connected information exploitation applications, some of them capturing decisions, other ones just being providing information, right, dashboards and so on. We've done that actually with a partner of ours, with Palantir. We're using Palantir Foundry as the underpinning technology for all of this. It allowed us to do one thing, not to make any silly technical mistakes. We've actually made some of these mistakes. The first head of Stargate is sitting there smiling. We built a Hadoop cluster like everybody 12 years ago or so, right? And we thought that we just need to make it bigger, and then eventually we're going to get all this, right? Obviously, it's a very, very hard problem to solve when you're a couple of people doing that on a server that we borrowed from guys who are running the database. We literally got a server that was about to be thrown away. That's how it all started. Tough problem. So working with a strong partner, definitely a better strategy. It also took us a few years, right? Maybe 3, 4, 5 even before we realized that. But we've been working on this for almost 7. And this is where we are. We have 400 services and applications and almost 6 petabytes of data. So when we think about services and applications, these are data products and applications built on top of that. Every point on that chart is a data set. And they are charted here in proximity to each other because one data set connects to another data set, gives rise to a third data set, and so on. The connections between those data sets are sometimes very explicit. So we sit down, there's a design committee and says we're going to connect risk to finance by building this and that data pipeline. But there are also implicit ones. So a guy in one team decides he's going to take some data that he has access to, build a product, and then share it with a colleague in another department. So we have both of these. Every business unit, every group function, every supporting function is represented in that picture. The colors, actually, I'm not gonna, for certain reasons, I'm not gonna say which colors are exactly which, but you can imagine that there are business units with their core information and analysis that is built around it, data products that are built from that core information, usually coming from transactional systems. And then we have group functions popping out somewhere here, connecting things between. Then we have another business unit that is very far away, probably in terms of the business. Imagine that this is property and casualty, this is life and health, right? What they have in common is risk, internal audit, finance. So Stargate as a platform brings scale. 2.5 million lines of code. That is as much code as we have on the platform that actually generates data sets every day. 100,000 jobs. So 100,000 times a day, a Spark job or a SQL query on a database starts, produces an output. This output is then registered, and the users or the applications are notified that something was refreshed. It takes us about 2.5 million virtual CPU hours every month to run all of this. But almost 50% of our workforce uses the platform at this point. So we talked about measures of success, right, of adoption before. We started at 0. We're at 50% of our company, where, I don't know, 70, 80% is probably the target, right? Since being a knowledge company that operates mostly on data, that is probably where we need to be. So we've made inroads into making this a very important foundation of our day-to-day work. Now, it does bring scale. Now, you may say, but that must be awfully expensive, right? Can you actually get the value out of that? It's obviously very hard for me today in this talk that is on technology to talk about the value of all 400 use cases, but we wouldn't be here if they didn't bring that value after 7 years. But what I can tell you is that this scale has one fantastic property. We see what's happening on this one singular platform. We have a central team that very carefully monitors how things are done. And each time we see an outlier that requires optimization, design change, I don't know, query tuning or something like that, we do that. And we very carefully record all these operations that we've taken. At this point, and this is really plus minus maybe 1%, not plus 5 or plus 10, we know that we've taken out about 40% of the operating costs. So had we not have a single platform, but instead maybe have 100 disjointed, I don't know, Azure subscriptions with Databricks instances or AWS accounts, right, with Athena or something like that, we would have spent a lot more time on a lot more money, because we wouldn't be able to optimize the entire fleet of these environments. It just simply wouldn't be possible. You wouldn't be able to even run a single query to understand, what is the worst query across all these environments, or at least not without a very significant additional investment into building these features ourselves, right? But in principle, we bought them as part of our platform, and then we learned how to use them. So this scale brings some advantages, but also challenges. So let's recap first on the advantages. Cost optimization, I just mentioned. Observability. The big picture that shows our data mesh is exactly that. We know exactly where data is, where it's come from, where it's going, who has access to it, how recent it is, whether the flow of data that we see actually fits into our concepts of governance, ownership, and so on. Sometimes we set hard constraints, so we basically must know to do certain things, and it's not going to be possible to do it on the platform. And sometimes we put soft constraints where we say, you shouldn't be doing that, we're going to monitor it, and if you transgress, we will call you up and tell you to maybe design things differently. So for governance, right, it's an important thing, so I'll talk about it a little bit more. Maintainability, 2.5 million lines of code. So how many of these lines of code are still running the latest Spark and the latest Python? Every single one of them. Why? because the platform allows us to run upgrade campaigns. So of course, every single one means probably within 6 months or so, we do have a little bit of a lag, but we are able to run upgrade campaigns on all our code base. And if the owner disappears and the repository of code is not updated within a certain time, that usually means that the data product is not needed anymore, and we just eventually get rid of it. But if there is an owner, if something is needed, right, we will work with those data owners to make sure that the upgrade is actually applied. Sometimes it's completely automatic. It's very simple. Sometimes you actually need to sit down and do a little bit of work. I remember we started with Python 2.7, 2.8, something like that. Obviously, there were big changes, right? Similarly, Spark from version 1 to version 2 to version 3 changes, right? Like these were bigger campaigns, and we have a team that is dedicated to that. But in principle, we are up to date. What's bad? Well, first of all this organic code, right? All the work that we allow the users to do is never not always good, right? Most of it is probably bad, actually. The other thing is that because of the observability, we can introduce either too much or too little ownership, and like dialing it in such a way that we do not get back to, we don't relapse into data silos. But at the same time, we don't create a situation where everything is chaotic, right? It's tough. And we've been changing our policies over the last 7 years a couple of times, really trying to find the sweet spot. There's a fundamental question: does it matter if it's a little bit messy, right? Because sometimes it actually doesn't. For our business people, none of that matters, right? As long as it produces the right number or a reasonably good number that they can believe, it's fine, right? If it does not fit certain idea of perfection of an IT professional, data architect, or whatever, right? It may not actually not matter. So, very quickly on how we've done that and from a point of governance. We let everything grow, like this park that you open and you let everybody first walk around, chart all the paths. That was probably the first 4 or 5 years. We got to that point. Now, obviously, we've been watching it, and at one point we said, okay, we're going to tighten the screws a little bit. We improved our governance process. We changed some of the governance processes in such a way. We influenced our own policies, right? Rewrote some of them. And we got to that picture where of those 400 data products, most of them are very well cataloged. There is a process when you open those data products, close them, who's the owner, what is the purpose, etc. Do we have the rights, and so on. And my compliance colleagues would shoot me for saying that, but we're essentially, as technologists, we aim for a minimum viable level of compliance, right? I need to be convinced that more compliance is needed, and I need to be convinced with a lawyer showing me a document. Otherwise, I usually don't do anything. Now, where does this take us? Operating a data mesh at this scale definitely puts us in a good space in the competitive landscape, right? We believe that we've done it quite well, and that we have a chance of really having more information that is easier for us to locate and to use and turn into actionable insights than others. And I know that is something that you always do as a company that has a profit motive. But then there's this other thing, right? I didn't want to make this talk about AI, but that's obviously a very important thing. We've been building this already back then with machine learning and AI in mind, although what we actually did with the data was still relatively simple, right? It was not Gen AI in the ChatGPT sense. Now, in our industry, in the reinsurance industry that is highly regulated, or maybe the financial industry in general, we believe that the value of very good data foundations, where governance is almost completely automated, is one of the key points to success in implementing AI, not for a use case or two use cases, but for implementing it at scale, right? If I now want to add AI processing nodes into my 400 data products, I pretty much can do that today because I know exactly how the governance process will work. I know the provenance of that information. I know if it came from our clients, if we have the ability to use AI on it, whether the license for commercial data is allowing us that, and so on. So that's the short on about our data mesh. Thank you very much. Are there any questions?
So I start with a question, and is there a use case you feel is neglected in your industry?
Use case that is neglected in our industry. I'm sure there are. So when I talk about the fact that we ideally would like to have this hypothetical database of all risk, right? We have a tendency not to go to markets that are not at a glance commercially interesting, right? So obviously companies like ours will operate a lot in Western Europe, in North America, right? In the industrialized part of Asia. But there is so much more opportunity, right? There are billions of people around the world, right, that are underinsured, right? There are areas in developed countries that are underinsured. If we had a database of all risk, that is the entry point to everything, right? So it wasn't just a pure sort of immediate business decision that drove us, right? If we really took the time to, I don't know, profile and catalog all the people in sub-Saharan Africa, for instance, we would have the ability to proactively design insurance products in these areas, right, as well. We do it a little bit, right, but it is still not something that is, at the front of our strategy. And if our strategy was entirely information-driven, I think these opportunities would be more prominent, right? But otherwise, we simply do not spend the time to gather that information yet.
Thank you.
So at the beginning of your journey, how did you convince people to break out of the silos?
At the beginning, we didn't. I'm still sometimes feel like my job is mostly convincing, and sometimes the same people, many times. We obviously needed to demonstrate success early on, and the initial part of the program was designed to focus on value demonstration rather than on building foundations. So we started with a use case first approach, where we tried to find the most lucrative opportunities where we can showcase the value of data integration in ways that were not possible. We actually, through complete serendipity, hit a jackpot where a 3-digit million use case was located and executed on the platform. And you can argue whether how much of that was the platform and how much was just prioritizing that use case, right? But it helped, not gonna lie. The work on foundation and even recognizing that what we build is essentially our interpretation of data mesh came much, much later, right? I don't remember when the data mesh article was published, but I think we started before, and then when we read it, we were very angry that we didn't write it, like it's one of those cases, right? But we definitely started with a use case-based approach. We started with shortcutting our data ingestion as well. We leveraged the existing data warehouses, integration points that we had. We didn't start with trying to replace the whole landscape, right, and build the ocean, right? We are now at that stage where we're finally removing things which are obviously redundant and in the legacy landscape, but it took us a while.
Thank you. How much do you rely on unstructured source of information like news and Facebook and messages and all this stuff?
We do actually. So it's an interesting question because even before we started that specific journey, we were part of a sort of data science team that did a lot of exploration in that area. At that time, a lot of these things just didn't work out, and now we understand why, right? Because our ability to process unstructured information at scale was just not what it is today, right? Today, completely paradigm change. As of this moment, we are actually in the process of consolidating our unstructured information and connecting it fully to that data. It's already there, but like industrializing it to the same level as structured information. If you ask me about proportions, I would say that it's probably still niche compared to structured, but because of Gen AI, we are absolutely certain that it's not just not going to be niche, but it's probably eventually going to overtake what we do with structured information. Because let's be very honest, in our business, where a lot of our business is custom in a way, and a lot of detail about that business is in unstructured information rather than in structured, right? These are big contracts, right? Hundreds of millions of dollars sometimes, lots of nuance. A lot of valuable signal for us is in the unstructured information, right? The structured, of course, is valuable, but every insurance company will have access to a database of buildings, you know, the I don't know, time series of earthquakes and so on, right? That is actually not that differentiating. But getting a good idea of what is coming from our clients as well as from commercial sources in the unstructured space might make the difference, right? And we absolutely do work on this, and we just expect it to grow.
Thanks, Lukasz. Thanks so much for that interesting talk. Lukasz will be around for more questions. I know there are more questions in the room. Wonderful afternoon. We'll meet again 2:05 with Amit from AXA. Thanks, Lukasz.
Thank you. Thanks.